Hello everyone, welcome back to my channel. I am Vandana, student of Sri Venkateshwara College of Engineering, Bengaluru, from the Department of Information Science and Engineering, 4th semester. Today in this video, I am going to discuss about the subject Analysis and Design of Algorithms. Subject code is BCS 401, particularly about the topic Analysis of Algorithm Efficiency. Analysis of algorithms. Analysis of algorithms means to investigate an algorithm's efficiency with respect to resources, running time and memory space, time efficiency, how fast an algorithm runs, space efficiency, the space an algorithm requires. Typically, algorithms run longer as the size of its inputs increases. We are interested in how efficiency scales with respect to input size. Analysis frameworks, measuring an input size, measuring running time, order of growth of the algorithm efficiency functions, worst case, best case, and average case efficiency. Measuring input sizes, almost all algorithms run longer or longer inputs. Therefore, it is logical to investigate an algorithm's efficiency as a function of some parameter n indicating the algorithm's input size. Input size depends on the problem. Example 1. What is the input size of the problem of sorting n numbers? Example 2. What is the input size of adding 2 by 2 matrices? Units for measuring running time. The next issues concerns units for measuring an algorithm's running time. Should we measure the running time using standard unit of time measurements such as seconds, minutes? However, depends on the speed of the computer, depends on the quality of your program implementing the algorithm. One possible approach is to count the number of times each of the algorithm's operations is executed. Difficult and usually unnecessarily count the number of times an algorithm's basic operation is executed. Basic operation, the operation that contributes the most to the total running time. For example, the basic operation is usually the most time consuming operation in the algorithm's innermost loop. Order of growth. Most important, order of growth within a constant multiple as n tends to infinity. Example, how much faster will algorithm run on computer that is twice as fast? How much longer does it take to solve the problem of double input size? Input size and basic operation examples. Problem. Searching for key in a list of n in items. Input size measures number of list items that is n. Basic operation key comparison. Problem. Multiplication of two matrices. Input size measures matrix dimension or total number of elements. Basic operation multiplication of two numbers. Problem. Checking primality of a given integer n. Input size measures n size equals number of digits. Basic operation division. Problem. Typical graph problem. Input size measures vertices and or edges. Visiting vertices or traversing an edge. Worst case, best case, and average case efficiency. Algorithm efficiency depends on the input size n. For some algorithm efficiency depends on type of input. Example sequential search. Problem. Given a list of n elements and a search key k, find an element equal to k if any. Algorithm. Scan the list and compare its successive elements with k until either a matching element is found. Successful search or the list is exhausted. Unsuccessful search. Here you can go through the sequential search algorithm. We have given input an array A 0 to n minus 1 and the search key k. Output we can get returns the index of the first element of A that matches k or minus 1 if there are no matching elements. Worst case, best case, and average case efficiency. Worst case efficiency. Efficiency for the worst case input of size n. The algorithm runs the longest among all possible inputs of size n. Best case efficiency for the best case input of size n. The algorithm runs the fastest among all possible inputs of size n. Average case efficiency for a typical or random input size of n, not the average of worst and best case. Summary of the analysis framework. Both time and space efficiencies are measured as functions of input size. Time efficiency is measured by counting the number of basic operations executed in the algorithm. The space efficiency is measured by the number of extra memory units consumed. The framework primary interest lies in the order of growth of the algorithm's running time or space as its input size goes infinity. The efficiencies of some algorithms may differ significantly for inputs of the same size. For these algorithms, we need to distinguish between the worst case, best case, and average case efficiencies. Thank you for watching this video.